Hello viewers, in today's session we are going to discuss an important and conceptual problem from application of derivatives, right? And here we have to show using the concept of derivatives that this number, that is e square minus 1 over e, is less than pi square minus 1 over pi, right? Now see, here we have to prove this inequality, or this expression, that is e square minus 1 over e is less than pi square minus 1 over pi, using derivatives. But if we take the particular values of that is e and pi, we can easily prove it, right, by simply substituting e is equal to 2.71, because the approximate value of e is 2.71, e is the exponential number, and pi the irrational number, that is 3.14, right? So e and pi are both irrational numbers, and their approximate values are given by 2.71 and 3.14. So if we actually substitute these values in this inequality, then we can easily see that this expression is less than this one, right? But here we'll show this statement with the help of derivatives. So whenever we have to prove these kind of statements, the first step is to frame an appropriate function, that is y is equal to f of x, right? So here we'll take the function as x square minus 1 over x, because this function is compatible with these two expressions, right? So we'll take x square minus 1 over x as our function, right? And here we can obviously see that the domain of this function is r minus 0, because in the denominator we have x and this function is not defined for x is equal to 0, so x should not be equal to 0, right? So the domain of this function is given by all real numbers except 0, right? Okay, now let us differentiate this function f of x. So let us write f of x as x square over x minus 1 over x. So this is simply x minus 1 over x. Now differentiating both sides, so we have f prime of x is equal to 1, the derivative of x is 1, and the derivative of 1 over x is minus 1 over x square. So this is 1 plus 1 over x square, right? And now we can see that this expression, here we have 1 which is positive, and 1 over x square, because x is taking all the real values except 0. So 1 over x square is always greater than 0 for all x belonging to the set, that is r minus 0. So 1 over x square is always going to be positive. So when we add 1 to 1 over x square, then this entire term is positive for all values of x belonging to this interval or this set, right? So we can see that the derivative, that is f prime of x, is always greater than 0, and this is the condition for f of x to be an increasing function, right? Because the derivative, that is f prime of x, which is dy over dx, is greater than 0, because 1 plus 1 over x square is a positive quantity. So this expression gives us the result, that is f of x is a strictly increasing function. So now let us quickly see the concept of strictly increasing function with the help of this graph. So let us consider an increasing function like this. So this is an increasing function, say y is equal to f of x, right? And let us take 2 points on this curve, that is a and b, and here we have say x1, and here we have say x2, right? And from this graph we can see that this value, that is the value of f of x2, is always going to be greater than f of x1, right? So whenever we have an increasing function and we have 2 points A and B on that curve, and if we take 2 points say x1 and x2 as abscissa, then the ordinates are fx1 and fx2, right? Since this curve is an increasing curve, so we have f of x2 is greater than f of x1, right? So this ordinate is always greater than this ordinate whenever x2 is greater than x1, right? So this is the definition of strictly increasing function where x1 and x2 belongs to the domain of the function. So we have just proved that this function f of x is a strictly increasing function. So let us take x1 as e and x2 as pi, right? Now see, e is 2.71 and pi is 3.14. So this number, that is 3.14, is obviously greater than 2.71, right? So pi is greater than e. So by this definition, because pi we are taking as x2 and e as x1, this is pi and this is e. So when x2 is greater than x1, then for the strictly increasing function, f of x2 should also be greater than f of x1. So it implies that f of pi should be greater than f of e, right? And f of pi can be obtained by replacing x by pi. So we have pi square minus 1 over pi greater than f of e, and f of e can be obtained by replacing x by e in this function. So we have e square minus 1 over e, right? And this is our desired expression or the statement where we have to prove that e square minus 1 over e is less than pi square minus 1 over pi. So this is how, by the method of increasing functions and the concept of derivatives, we can tackle these kind of problems.